Hi, my name is Deepak, and today we are covered about IP SLA. What is the IP SLA actually? Internet Protocol Service Level Agreement is there. Why we use the IP SLA and what is the IP SLA? If you ask that question, then I have the answer that IP SLA is a part of Cisco iOS, means the internet network operating system that allow users, means you means network engineer, means IT admin, to analyze IP service level for IP application and services by using active traffic monitoring. IPSLA send data across the network to measure performance between multiple network locations or across multiple network paths. IP SLA is layer 2, means data link layer transport independent. It means is that this is Cisco priority protocol and its work on the data link layer. It's layer 2 protocol is there. Actually we can trace a lot of the features is there. We can monitor the IP SLA, monitor the track, or we can say that the network performance, link performance with using the ICMP, DNS, ICMP reply, and many of the other features is there. Let's go. We will discuss about that features. You can see. Let's see how to configure IP SLA on Cisco router and troubleshooting. Today we are going to discuss him. Now you can see this is the 4 router is there: router 1, router 2, router 3 and router 4. And you can suppose this router 1 is our branch office network, or our H office network is there, and router 2 and 3 and 4 are our ISP router. You can suppose that we configured everything on the router 1, router 3, router 2 and router 4 are under the ISP or other team, so we can't be configured anything. That's not very. We have the some addresses as same. You can say that we have the one public address as the Google DNS 8.8.8.8 and some other DNS servers or some other well-known services. We know that the servers are lump sum 99.99% uptime guarantee is there with the servers. So we configured the type of the ICMP. Today we discussed with only ICMP. After that we will in the next video we will discuss with the DNS or other things. Let's so with that this you can suppose that there's the 4 router: R1, R2, R3 and R4. Let's go with some details. Here router, I have the 4 Cisco 2690 series router. That is in my theory. That is my notes actually. In the notes I was made with the 2960 router, but I am doing the practical with the other model of the routers. So don't be confused. iOS version is there, some command will be changed, but everything the concept is the same. R1 is configured with the default routing and IP SLA for use backup link. R1 and R2 link is used as a primary link and we track the same link, but in practical we need to track an option as he given guarantee for 100% uptime or our last endpoint. As in the real network we can use 8.8.8. You can search this the well-known Google DNS server. I was told you before that. Here the network I am using, the address is 3.3.3. the loopback address of on loopback address of R4, means I configured the 2 loopback address on R4 is the 3.3.3 and 1.1.1.1. okay. Note in the practically we use the IP SLA on static routing because dynamic I have capability to choose best path with metric calculation, so we can make changes in metric as required. Some basic steps before we move to practical. This is the question, is the why because you can see here I told you I earlier told that R1, R2 and R3 I configured the ESGRP, but in the R1 I am using the static routing. Why we are static routing? Because EIGRP is dynamic routing, and dynamic routing has the capability to choose the best route automatically. If one route goes down, it will be send your traffic through the another route, your backup route, you can say that, or you can make a load balancing with that route. This is the real thing. Today our topic is we are going to discuss with only static route. So I configured the static route on R1. How I configure that, I show you everything. But first we know the some basic commands is there. IP SLA service level. You must have the 2 or more ISP link for outgoing, where you are going to configure track with IP SLA. And the second point is that you must start IP SLA now or with delay as requirement. You can configure I said earlier that you can configure the IP SLA as per your requirement. You can modify that. You can modify the delay threshold, and many of the more features is there. Must be configured track to apply IP SLA on routing. Track is working as intermediate for IP SLA and routing. When we configure the IP SLA, okay, we first configure the IP SLA. We define that this is the IP SLA value, and which from the which interface, and which IP you can going to trace with them. But after that you will configure the one track command is there. I will show you that how we will configure the track. Must configure backup route and with a static floating route, backup route with highest ID value. What is that is the one option is that static floating routing. Static floating routing means one or route with highest you change the default value and make the high floating routing with them. And how we will configure that, I will show you the everything. Some basic, if you want to know the some about the some commands, we are going to check here. IP SLA monitor 1. This is the command. Actually the command will be changed as per your iOS version. So as you know that my nodes I was created with the 2900 series router, but I configured delay with a different on different version of the router is a router C2700 series router. So command may be little change as per the iOS version, so don't be confused about the time commands. If you have if you are facing any difficulty, so you can check with release note, the Cisco release note. For all type of the commands, they are providing the all type of the commands, what they made changes, and what the command is changes, everything they are providing that. But I am talking about the some basic commands. IP SLA monitor 1, configure the IP SLA monitor 1. You can use the ISLA monitor. There are a lot of the ISLA monitor is there, you can use on the Cisco routers, but be careful to choose the more IP SLA monitor, because they are consuming your bandwidth, and they using your CPU also. There is router resources also they are using, so be care about that. Type echo protocol ICMP echo 3.3.3 source interface fast Ethernet 0/0. The second command is we are going to type is the type echo protocol. Type means type we are choosing about the IP SLA is the echo, and protocol ICMP echo, and the IP address which we are going to monitor is 3.3.3 source interface fast Ethernet 0/0 is there. Here we use the operation type of the echo, and the protocol IP echo I use the address 3.3 and endpoint IP which I need to monitor, and source IP or IP address which link we need to use the primary link. I will clear something because there is some doubtable question is there. This is our model. Here I am going to configure is there the no 3.3.3 is there, because I want to monitor this link with public IP. What will happen, sometime we can monitor with this interface also, physical interface also, but what will happen that that link is okay, but this link is break down due to this router, or this link is will be failed, then what will happen? So at that type of the question, our IP SLA will work fine, but our traffic will be not reached on the destination, and or users will be failed to access the internet or some other services. So I'm monitoring this IP because this is the loopback IP. You can say, you can compare it with your Google DNS server, that because we know that Google DNS uptime is 99.99%. So you can see that there is the IP SLA. I configured everything is it here, and I'm monitoring this IP because what will happen if the internet will be goes down due to your ISP side, and this link will be up. Then what will so we are monitoring the complete path for the destination. So that's why I'm monitoring the 3.3.3 because this is the lab. So I have only 4 router in my lab. Well, let's we go to the downside and we'll check everything. This is the time at then how much time in millisecond wait for the reply. You can see how much take gap between two IP SLA echo packets. Tag user defined tag, we can save the tag, and we can configure the VRF name if we are using the 2 or more VRF in that. And we can use the type of the services also, means your QoS services also we can configure here, and threshold value we can also configure is there, and the time in the latency we can configure it there. This is I was talked already about that. We will start right now or schedule as per we need. This is the command IP SLA monitor, schedule one live for over time start now, and this is the track. After the configuration we need to track that. We have defined the track 1, RTR 1 and reachability, means that IP SLA 1 it should be reachable, track that. And this is the route. You can check that we have configured the one default route, and this is the track 1. I enable the track 1 here on the IP SLA IP route. Okay, I can show you some configuration here. That this is the I configure the IPS. This is the configuration on R1. This is the R1 configuration, IP SLA monitor 1 echo type. This is the command is there, and frequency 30. IP SLA monitor 1 schedule 1 live forever start time now. Track 1 RTR 1 reachability. That's a track I configure. This is the interface configuration, and this is you can see. I have told you that static floating route or default floating. This is static floating route we called in the technical one. This is the default route I configured it there. This is the AD value I changed because the default AD value for the default route is 1. I changed it to 2. So it is the second priority, and this route you can check. There is the no default AD value changed, so it is the by default it's it have the AD value 1. So this is the R2 configuration. You can check that nothing is configured on the R1, only I configured the EIGRP, and this is the interface configuration. Nothing I configured on R2 and R3, and you can check on the R4 also. Nothing I configured on the R4, just I configured the two loopback address, one loopback 1 3.3.3 and loopback 2 is 1.1.1. You can see in my picture on my left that I have defined it that, and this is the EGRP. Nothing is configured is there. Let's see the practical is there. I'm coming, and that maybe some command has been changed. You can see this is the IP value statics. I am going to change it, check is that I want to check is that the IP SLA is working or not. You can check that RTT is 45 millisecond, and the last operation the operation start was the 6:24 p.m. and you can see the number of success is 23, number of the failure is 5. Number of the failure 5 during the configuration, my lab configuration, it was some issue with EAGRP configuration, so that goes failover. and I will check the this is the IP SLA static, this is working or not, because this is the written code. You can check that if this written code is okay, then it's okay, it's working fine. Now we are going to check the track. Sorry, some issue with my keyboard actually. Yeah, I will show you something at in my document for, so IP route, I will show you first route is there. You can see this is the route. Currently we are going through 10.10.2, okay, and 10.2 is connected to 0.0. If you see your configuration and the R1, you can see the 10.2 having the latest the smallest AD value, so our traffic should be go through the 10.2. okay, now this is correct, and here you can see I will show you everything. The path is connected to the 0/0. This is so track I will show you IP SLA. I will already shown to you. We are going to check so track. You can see that track reachability is up, okay, and one change is made in that before the 22, and the last operation written code is okay, and the latest RT millisecond is 7, okay, and the static routing is 0. This is running fine with, and that we already checked that so IP SLA statics. Now I'm trying to ping 3.3.3. you can see I'm getting the 3.3.3, and now I'm trying to trace route 3.3.3 to verify the how data is reaching to. You can see the traffic is reaching to 10.2, after that is reaching to 13.4. the same thing you can see, okay, the route is the same, 10.2, after that reaching to 13.4, which is the R4 IP address. Now let's see what will happen after shut down the physical interface on R4 to R2. okay, here if I shut down this interface and R2 the F0/0, I will be shut down this, because currently our traffic is going to this way from R1 to R2, R2 to R4. the traffic is going this way, okay. I'm going to log in R2. Oh sorry, something is, yeah, I will show you something. Sorry, so IP route, this is the routing table. This I configure the ESGRP in the routing table, and I'm going to configure shut down the interface. First you can make 0/0, making to shut, okay. You can see this ESGRP reachability has down. Now check on R1. So IP SLA monitor, sorry, so IP SLA statics, because its timeout is not expired, so just wait for the timeout. This is, you can see, now you can see this is the timeout, and this is the event which is generated by the track status, the tracking state 1, IP SLA 1 reachability is down. Okay, now if you will check so IP route, then you can see now traffic is going through 11.3. Okay, if you want to, I'm sorry, this cute I configured it. So you can see the so tray, the reachability is down and written code is timeout. Okay, and this is the same thing I show you, that this is the event, the AGRP has down, the instantly shut down, and this is, you can see that reachability has time change out. So if you seen this, so IP route, you can in the R1 you can change the this route is already automatically changed. Okay, now we will verify that how it is working on that traffic, how traffic is going on. Again, I'm going to check the 3.3.3 the RTR. Now you can see this traffic is reaching to 11.3 and reaching to 12.4. And if you want to see the previously, then I will show you something how the traffic was reached there. You can see that the traffic was reached previously, it was through the 10.2 and 13.4. okay, the currently the traffic is going through 11.3 and 2.4. What the meaning of that? Currently the traffic is going this way. Means for now our backup link is activate. Okay, now again I'm going to make no shutdown command here. Okay, just wait, the traffic, the AGRP never has come up, and now I want to check. So IP SLA statics, it's timeout, just wait for a few seconds, it's it will be, check it again. It will take some time because it will check the reliability also. What will happen? Why it's not come up? Yeah, you can see that the tracking stat has come up again, the IP SLA. Now if you will check the so IP route, the traffic is moving back through 10.2, and I will show you something when I configure. I will show the some running configuration right here. I told you previously that I already discussed with you that there are some configuration changes as per the iOS version. You can see the type command is missing here. Only I simply reply that how we can say that how many options is there, you can how to configure your IP SLA. I will show you IP SLA 1. IP SLA, we can't be edit right now because this is IP SLA is working right now. We should be shut down it and we remove the track option. After that we can make the changes in IP SLA 1. Okay, now you can see that we can configure through the DSCP, DNS, Ethernet, FTP, HTTP, echo reply, echo path, path echo, MPLS, path jitter, TCP connect, UDP echo, and UDP jitter. We can configure like many of the options is there. We can configure in that. Today we seen that ICMP echo, and in the next video we will see with the DNS and HTTP. Thank you so much for watching this video, and please subscribe and like this video. Thank you so much.